So yeah, number one is a limit. Obviously, number two, obviously it's got a table there asking you for the minimum number of times there were 50 students in the commons. And as you can tell, number three is a do you know how to find a derivative? Lots of different forms of things and how. We'll see how that goes. And we're finding dx of g of x. Take about 10 minutes to do this, and then we'll check some answers. Okay, so number one, answer is -1. So we're going to find out that American Hunter, maybe others, use the calculator to evaluate number one. It's great. I would want you, in the end, I would want you to be able to do number one without a calculator. We can talk about how that happened if you'd like. Number two is an IDT question. Notice the condition there. I mentioned that NFT is differentiable, as we stated in the question. Therefore, NFT is continuous. That condition is crucial for the IDT to be valid. So you want to have for sure mentioned that in your somewhere there in your argument, your discussion, whatever your conclusion was. And then I came up with 3 times at least. And then for number 3, you can see kind of a final, somewhat simplified, sort of nice looking answer there for number 3. Okay, so I know for sure there will be discussion on number 1. I think I know at least one person that did number 1, seemingly without a calculator. There could be others. If that was you, nice work. But maybe for the moment, do you guys have any questions on 2 or 3? We'll come back to 1 at the end. I'm a big fan of what-if questions. Sometimes I'll have a good answer, other times not. But it's what if this was different? So maybe you got this one right, but you're wondering about something that wasn't there. Would that change things or whatever? Always be a good discussion. So let me ask you a question. Have you started to realize that with the derivative skills 1 stuff that we're doing right now, that you need to have those like rock solid? Like derivative of sine. You can't be like, I can't remember. Like these things need to be, you need to be really well versed. And we'll keep practicing them, so it's not like it's just a one and done thing. But all those for sure need to be really good.
I just have a more general question for
Yep.
like the AP test. Will they expect us to be able to both evaluate derivatives both with the limit and the definition of secant line and tangent line, or can we just hop straight to the power rule?
Great question. So I would say, well, not everything is a power rule, of course, right?
Yeah.
Derivatives of e to the x and cosine, etc. So I would say the vast majority of the time, your knowledge of these derivative skills 1, that's going to be just fine.
Okay.
However, as far as the using the limit definition, like the limit is h approaches 0, that whole thing, I cannot think of a time in the last 20 years where they have asked you to find a derivative and show your steps using that. However, number 1 on this is how they would assess that.
Okay.
Maybe this will be a good segue to number 1.
Because you know what the groups are.
Yeah, so let's go there. Let's go there. So, Carson, I saw, it looked like you did number 1 without a calculator. Is that true?
Yeah.
Do you want to explain what your thought process was?
Well, it's just the derivative of the cosine of pi over 2, which is like negative sine of pi over 2.
Okay.
Because it's f of x plus h minus.
Yeah, that's kind of where I want to go with this. So if we did limit as h approaches 0 of f of x plus h minus f of x all over h. So here would be, I'm going to show you later on this year, I'm going to show you a totally different way that you could have done number 1 without a calculator. But without a calculator, here's what I hope, and Carson pretty well spelled it out, what I would hope that you would do with this. And make no mistake, number 1 was hard, wasn't it? Yeah. I mean, if you, let me put it like this. If you saw it, it was really quite easy. Like if you were like, oh, I know what that is, it was very easy. But if you didn't say, oh my goodness, that's the derivative, it was almost impossible, wasn't it? really difficult. So just like Carson said, I would want you to look at the thing that I have up there printed on the paper and say, wow, this looks like the definition of the derivative. Right? You have that aha moment. Oh, it's limit as h approaches 0. There's a function. It's kind of an x plus h. And you would say, well, this is kind of like that, and this is just like that, and this is kind of like that, and wow, you know, this is kind of like that, and this is kind of like that, and wow, look down there in the denominator. This thing right here is just like that thing right there, and wow, that's the same. You'd make all these little comparisons and say, it's the derivative. Does that make sense? That'd be step one. In your mind, you'd say, wow, that's the derivative. And then you'd ask yourself, great, it's the derivative of what? Derivative of what? Now, Carson said it's the derivative of cosine of pi over 2. And I think we all understand what he's saying, but he's a little bit off. How would you rephrase that?
The derivative of cosine of x evaluated at pi over 2.
And that's an important distinction, right? Because the way that you find the derivative of cosine evaluated at pi over 2 is you find the derivative first in terms of x, and then you plug in the whatever the number is, in this case pi over 2. So it's a derivative of what? The answer to that question is cosine. Here's where your knowledge of derivative skills would be important, because you'd say, well, the derivative of cosine is negative sine. And then finally we'd say, well, it's evaluated at the x value, pi over 2, evaluated at pi over 2, and that's, of course, where we come up with negative 1. So this question was really intense because, number one, it made you think about the definition of the derivative, hopefully. Number two, it made you think about your derivative rules. And then number three, to top it all off, you had to know your unit circle. So it's a pretty innocent, tiny-looking question. There's a lot packed in there. A whole lot of stuff packed in there. Okay, so what do you think? Questions? Kim?
So with how do you necessarily write that so to show your
Yeah, so I think it kind of depends on the question format. If it's multiple choice, we're not even talking about this. If it's open response, I got to say, open response, I would be fine. Here's the original question, obviously, boxed in green. If all you wrote was that, I'd be okay with it. I really would. I would say they're either the luckiest guesser on earth, which is highly unlikely, or they know exactly what they're doing. What do it? Anyways, good question. I guess the longer answer to your question is, on a standardized test like the AP test, probably a 100 times out of 100, or maybe 99 times out of 100, that's multiple choice. So we don't even get too concerned about showing work. Yeah. Anybody else with a question? Okay. So then, today is really similar to yesterday. So I'm hoping that either one of two things is true. From yesterday, I'm hoping that either you are feeling really comfortable with tangent lines and that kind of thing, or maybe you're feeling uncomfortable with tangent lines. In either case, we're going to do more tangent lines today. So you're either going to go from uncomfortable to more comfortable, or from comfortable to even stronger than you were yesterday, hopefully. And these are all going to be done in a little bit of a different light. These are all going to be using mostly the functions that we did not look at yesterday. So yesterday we looked at cosine and sine and power rules and rewriting of power rules. You notice right off the bat, it's a graph of log base 7 of x. So this will get us into the rest of our derivative skills 1, as far as the derivative of this and that, and so on and so forth. We should be able to fill all the rest of these out. So if you wouldn't mind, take a look at number 1. Let's see how you're doing. Maybe you're doing great. Maybe you are feeling a little bit shaky. In either case, please try number 1. It says, write an equation of the tangent line to the graph of y equals log base 7 of x when x equals 49. Reese?
For a question like this, will we have a calculator?
I would say no.
Okay.
I don't.
So we can leave our slope value values.
Yeah, totally. I think, if the you're going to learn soon that if the calculator was active on a question like this, it would really very much change our approach completely. There are going to be certain tools in the calculator. Yeah, you can find numerical derivatives.
Yeah.
And so I would say, if this were a quiz question, I would for sure put it on the no calculator, because I want to make sure you actually know where these numbers are coming from. somebody that's savvy with the calculator could start right on around that. So, kind of depends on the format, the timing of the question, really the time of the year too. Later in the year might not be that concerned about it.
Do you mind flipping over your distraction? Thanks.
So I'm giving you guys a little bit of time to kind of run with this. You might be stuck. I'm looking around and I'm seeing folks are like either reading intently or writing, so I think you're making some kind of progress, perhaps. But here in a minute, I'll give you a refresher on how we do this, things we got to have, what the result might end up looking like. Okay, I'd like to kind of guide you guys through a solution here, and again, I hope we're getting to know each other well enough where if I say something that's confusing to you, or you've somehow confused your own self, that you're going to raise your hand and say, wait, why, what? I don't get it, right? I hope we're friends enough to at least do that. You guys okay with my graphical representation of a tangent line?
Yeah.
Looks reasonable? Okay. So what would you guys call that point right there? Point of tangency, yep. So that's that terminology I want to make sure we're all trying to use here. Point of tangency. So as you guys know, a lot of important stuff happens right there. Kind of determines the course of the line and everything else. So what are the two things that I got to have to find the equation of this lovely blue tangent line? Got to have the point of tangency, yep, and the slope of the tangent line. Would you guys agree with me that maybe the point of tangency is the easier of the two to find? I mean, that's debatable. It's not always going to be the case, but here maybe it would be. What would I need to do to find the full point of tangency? Yeah, yep, just evaluate that. So y would equal log base 7 of 49. Hope you're all good at your logs. What's log base 7 of 49? 2. 7 to what power is 49? The answer is 2. So I'd say my point of tangency is 49, comma 2. And you can see the graph is actually pretty accurate. This is just a graph off Desmos, and so it's should be pretty accurate. So I found my point of tangency. So if I wanted to, I could come over here and say, well, my answer is going to be y minus 2 equals blank times x minus 49, right? What's supposed to go in the blank where I put the question marks? I don't have the slope yet, right? I'm going to have to use the derivative to do that. So I'll come over here and I will attempt to do that. In order to do this, I need to be able to find dy dx. So what's dy dx if y equals log base 7 of x?
1 over natural log of 7.
There we go. Yeah, 1 over x ln of 7. Okay. And that would be right off of your little derivative rules page that you got back a few pages ago. Okay, so if I were just to take this and drop it in where the question marks are, am I good? No. Yes? No, I'm hearing some yeses and nos. What's wrong with that? I got to plug in a 49, right? Because I don't care about the slope of the curve at any point. That's what that is. I want to know the slope of the curve at my point of tangency. So like you said, I need to plug in the 49. So it'd be dy dx equal, or sorry, dy dx evaluated at x equals 49 would be 1 over 49 ln of 7. And that's what I would actually drop in there, because that's the slope of that line, or excuse me, that's the slope of that curve and that line at the point of tangency. So if I write that in here, 1 over 49 natural log of 7, that then would be my complete and final answer. Bless you. Okay. What can I help you with? That sounded awesome in my head. Might have sounded terrible in yours. I don't know. So if I've confused you or something seems unclear, or where did that thing go, or why did that thing just show up like magic, let me know. Okay. Well, I will take your silence as good silence, because that's what I choose to do. Let's try number 2.
So would we just leave it how it is?
I would leave it how it is, yep. In fact, some people get uncomfortable with that. They're like, whoa, we need a decimal number for the 1 over 49 ln of 7. I'd say the mathematician in me says, that's better.
Would you like us to add 2 to the other side or just leave it on the left side?
I don't care, whatever you like. You know, WebAssign's going to care, right? WebAssign wants it to be y equals a lot, so they care. I'll leave that up to you.
Okay.
Yep, I'll leave it up to you totally. I know in Algebra 1, like you're preached at, like you must go to slope, intercept, and if you don't, there's something wrong with you. We don't care.
Okay.
Yep. Anybody have any questions on number 2? Oh, sorry, my bad. Say what you were going to say.
Why is there like 49 on the outside? Like how?
Why is there 49 at the outside?
Yeah.
Which 49 are we talking about?
So the 1 over x out and 7 y side.
Outside of what?
Well, the bottom that was 1 over L and 49 was outside.
Okay, so you're confusing two things. So the function is y equals log base 7 of x, right? So we knew that our point of tangency was x equals 49, and we wanted to know the y value. Of course, the way you find that is you take your 49, you plug it in for x, and you evaluate, right? So y equals log base 7 of 49. So that means the 49 is the input into log base 7. And if you know your logs, you say 7 to what power is 49? The answer is 2. Now, so this is trying to find the point of tangency, to find the slope of the tangent line. I've got to find my derivative first. So dy dx, that's what I'm looking for. I'm looking for the slope of the tangent line. This equals, this might be where we're getting tripped up. It's 1 over x natural log of 7, like x times natural log of 7. This goes back to your derivative rules, and I can show you how to change the base and prove that this works for you. Yeah, I'd be happy to do that, but on the other level would just be, okay, this is the derivative of that. This is the derivative of that. So I want to know what the slope of the tangent line is when x equals 49. That means I plug a 49 wherever I see an x. So it'd be 1 over 49 times the natural log of 7. So it's not like ln of 49 or log of 49. It just comes from changing the base. Like, I don't know if most people just do this on their calculator these days, but did you know that this is equivalent to that? You change from base 7 to base e using what's called the change of base formula or change of base process or whatever. And then if I'm going to differentiate these, I get ddx of log base 7 of x. This is just a constant multiple. What's the derivative of ln of x? This is from your derivative rules page. You haven't copied that down, you need to. The derivative of ln of x is just 1 over x times the constant multiple. And you can probably see how this is the exact same. So that's the long and short of it. I think that's a pretty long answer to your question. Did it okay? Okay, we're working on 2. Anybody? I was talking with Carter over there for a few minutes. Does everybody know what normal line is? Perpendicular to the tangent line, yeah. So if you ever had a physics class or something, you think about like normal force, which helps you find friction. And then when you incline the plane, all of a sudden the normal force gets a little weird, right? You got to use trigonometry and stuff to figure that out. Well, let's see here. So E, yeah, so your y value is definitely right. E to the x. So the derivative of sine of x is actually positive cosine of x. Yep. So other than that, I think that looks pretty reasonable. And did you flip your slope, or did you do the opposite reciprocal? Okay, sure. Okay, so again, like I was talking about with Reese earlier, I would put number 2 in the category of no calculator. Then I realized that's going to leave you with like a somewhat unsatisfying answer because we're always used to decimals and all that stuff. I'd say that in some ways this answer that we'll get here in a minute is better, simply because it's going to be exact. It's going to be precise. So if you're trying to find the equation of any line, whether it be normal or tangent or any other line, don't you just need a slope and a point? So let's find the point first. I would say, and this one's a little bit tougher, I would say my tangent line would look like this red line that I will attempt to draw. I don't know, that's okay. It's a reasonably good effort, I suppose. But everything is dependent upon what's happening at that point of tangency, right? So would you guys agree with me that maybe finding the point of tangency would be a good start? Okay, so point of tangency would be y of 1. And I just need to plug in a 1. And this is where the answer is a little bit weird. It'd be e to the first plus sine of 1. It would be tempting to think that sine of 1 is a unit circle angle, but it's not. Sine of 1 is some crazy decimal. We're just going to leave that alone. So I'd say my point of tangency is 1 comma e plus sine of 1. Point of tangency. P-O-T. Point of tangency. Yeah, e to the first plus sine of 1. And then the challenge here for us, of course, then is to find not just the point of tangency, but also the slope of the tangent line. So how do I find the slope of the tangent line? Find the derivative. Yeah, find dy dx. So dy dx equals, what's the derivative of e to the x? Yay, we love that. Plus, what's the derivative of sine of x? Positive cosine, yep. So that is your derivative in terms of x. I do not want my derivative in terms of x in the end. I want to find my derivative evaluated where? At 1. So I'd go dy dx evaluated at 1. That would give me e to the first plus cosine of 1. So, as far as my equation of the normal line, I hope that y'all would agree with me that it's going to be y minus e plus sine of 1 equals something times x minus 1. Now, what's the something that needs to go there? Slope of the normal line, right? So if the normal line really is perpendicular to the tangent line, what do I need to do with that e plus cosine of 1? Opposite reciprocal. That's right. So maybe something like negative 1 over e plus cosine of 1. Something like that be okay? Bless you. Say again?
What is opposite reciprocal?
So reciprocal means flip the fraction vertically.
Okay.
Opposite means change the sign from positive to negative or negative to positive.
Yes.
So
Right.
originally it was positive, like a positive quantity of e plus cosine 1. I just took whatever the result of that was and made it negative.
Okay, that makes sense.
And did the flip. Okay. You guys seem like calmly confident. Am I reading this right? That's obviously a good thing. I just want to make sure I'm reading right. Okay, fair enough. Let's move on to number 3. This is good. Okay. But, sorry, before we do number 3, I guess we need to talk a little bit about symbology. Sorry. I forgot this was here. You can tell I don't like pre-rehearse this stuff. Okay, so higher order derivatives. It's probably what you think it is. So I would say here, symbology-wise, d, like sometimes people say d squared y over dx squared. Nothing's really being squared. It's just the symbology of it. This means this is the second derivative. Second derivative with respect to x. Put second deriv with respect to x. So the symbology is important. And how would you guess you would find the second derivative?
Take the derivative of the derivative.
Yeah, do a derivative and then do a derivative again. So most people find that to be pretty intuitive, and that's right. Let's do a derivative and then do it again. What about f? The way you'd say that is f double prime? F double prime of 8? What do you think that would mean? Of f evaluated at 8. That's right. So second derivative of f evaluated at x equals 8. Evaled is evaluated. All right, what would you guess? Y with 3 little marks? Third derivative. Y triple prime? So third derivative. How do you suppose you'd find a third derivative? Yeah, just differentiate y 3 times. And by the way, once you get beyond a third derivative, the typical notation changes a little bit, and I'll show you with this last one. What would you guys guess the very last symbol means? Yeah, with respect to time, maybe? With respect to t, for sure? Yeah, so fourth derivative, there we go, derivative of y, whatever, with respect to t. Do you guys remember the German guy who came up with that notation? His name? So maybe somebody who was close. Leibniz? Somebody who was sort of close? Yeah, Leibniz. So Leibniz has that notation. Who came up with the prime notation? Newton did, that's right. If I was going to use Newton's notation for this last one, I would not do this. And for any subsequent derivatives afterwards, like if it say it was like a 5th or 6th or 7th derivative, you can see how this would just go on for a while. Instead of doing this, I would go y parentheses exponent 4. That does not mean y to the 4th. That means the 4th derivative of y. The parentheses are what indicate that. That'll be rarely, if ever, used in our course, but just an FYI. Yes?
Doesn't it also work where it's like IV?
Oh, like the Roman numeral IV? Yep, that works too. I would say a lot of people feel like Roman numerals are a little bit hard to write, and like IV might end up looking like triple prime or whatever. But yeah, that is very valid for sure. Okay, would you guys please then try number 3? This will be like more good practice with derivative skills 1. You can see that there's a bunch of them in there. Please try number 3. It says find d squared y over dx squared, which happens to be the exact same symbol as our very first symbol on the little chart. So please give it a shot. We'll take a few minutes to do this. We got 10 minutes left in our class, and I think we just have these 2 examples left. So let's take the time to try to do this right, do this the best we can. Great question. I think this is an example of those activities we did the other day where rewriting is the best. So that's the correct derivative of that. But then when we think one step ahead, like how are we going to do our next derivative? I would rewrite this 1 over x in that way. What do you think would be? The 5 is okay. I think we'll sort of leave the 5 as is, because 1 over x. Yep, I would do that. Merrick, you getting caught up from your extended departure there? We missed you. Some people even started crying. We had to pull out the Kleenexes. Hunter was distraught. Yep. So I'm kind of thinking of number 3. You might be kind of approaching like a good midway point. And I'd like to meet you there, and I want to kind of help you a little bit with something. So I'm mixing my symbols here, but hopefully that makes sense. Oops. I'm going to say f prime of x equals... Now let's just see if we agree on the first part of this. As you guys know, if you're going to find a second derivative, you're going to have a first derivative somewhere. What do you think about what I wrote up there? Any questions? Well, obviously, you need to get this right if you want to get the the actual final answer, right?
Where did you get?
What do you think, Hunter?
Where did you get the ln of 3?
The derivative of, this goes back to your derivative rules. So d dx of a to the x equals ln of a times a to the x, where a is some constant.
But wouldn't a be 5 instead of, wouldn't be ln of 5, not ln of 3?
No. For 3 to the x.
There's 3 to the x. I'm looking at, so this goes with this. They're a little misaligned vertically.
Okay.
Sorry.
Sorry.
I started off okay, but then I got kind of like skewed off to the right there. Made me think about that for a second. Did I like mess that up and get the wrong number in the wrong spot?
The 5 ln of x.
It would not be the first time, so it's okay. What do y'all think? You okay with the 1 over x? Anything in there? So let me ask you this: if you're going to go to a second derivative, what do you have to? What would you suggest to someone if they were going to take this and then move on to the second derivative? What might be like a little minor editing that would be very useful?
Rewrite 1 over x.
Rewrite 1 over x. I really think you have to do that here. So I would do just a real quick rewrite. And you could, if I were you, if I saw this coming, I would just automatically do this. I would write it as 5x to the negative 1. I leave everything else alone. This would then allow me to get to my second derivative easier than if I didn't do that. I'm just going to quietly write the proposed answer here.
What is the ln of 3 equal 1/3?
So ln of 3 is actually a constant multiple. So the way we deal with constant multiples is we like mentally cover them up, do the derivative of whatever we got to do, and then mentally uncover them.
Okay.
Oh.
You guys okay with ln of 3 being a constant? Sometimes we look at ln of 3 and say ln of 3, that's a variable. No, it's not. ln of 3 is some number. It's probably 1 point something, right? 1.2?
1.09.
1.09, okay, pretty close, I guess. So it's a constant. I mean, it's like an unconventional constant perhaps, but it's still just a constant. So take a look what I have up there. Now let's just think about it term by term. So 60x to the 4th. Feeling okay about that one? You have any questions? How about minus 5x to the negative 2? That's a power rule. Let me know if that's confusing at all. You could have rewritten that. Did anybody write it as minus 5 over x squared? Maybe you did, that's great. If you didn't, that's also great. That either way doesn't matter to me. How about that third term with the ln of 3 squared? Do I need to expand on that a little bit? Okay, let's talk about that. So let me just pull out the ln of 3 times 3 to the x. So if I'm right here and I pull this out over here, ln of 3 times 3 to the x. If I'm going to do the derivative of that, we need to recognize that ln of 3 is a constant multiple. Not just a constant term, but a constant multiple. In other words, it's a coefficient, right? Here's what you can do with that. Here's what maybe you should, either mentally or literally. You can bring this out of the derivative because it's a constant multiple and say it's really ln of 3 times d dx of 3 to the x. And then you do your derivative of the part that has the variable in it. So I'll just come over here, I guess. So it'd be ln of 3 times, what's d dx of 3 to the x? ln of 3 times 3 to the x. So maybe you can see how this would just be ln of 3 quantity squared. And of course, if you did a third derivative, wouldn't it be ln of 3 cubed times 3 to the x? If you did a fourth derivative, it would be ln of 3 to the 4th times 3 to the x. They just keep building with each derivative.
So, what's the difference between a constant and a constant multiple? Because if
Sure.
ln of 3 was just 4, wouldn't it come out of the derivative?
Well, the key word is multiple. So would you guys agree with me that 11 is a constant? It's a constant term. If I wrote it like this, if it was 11 times sine of x, Like if that was how the problem was, now 11 is not a constant term anymore. It's a constant multiple. In other words, it's a constant being multiplied times some variable expression.
Okay.
So as currently written right here, 11 is a constant multiple. As it actually was originally written, it's just a constant term, and the derivative of a constant term is 0.
Okay.
If you have a constant multiple, you bring it out, do your derivative stuff, multiply it back in.
Okay.
I usually do that mentally, but you can also do it like I did in red there.
Okay.
Great questions. Thank you for asking. What else? Okay, so then we got like 3 minutes left. Let's maybe do number 4 together. Number 4 looks sort of intimidating. Oh, and by the way, Kaylin, did I answer your question?
Yeah, I don't remember.
I said, how's everybody doing with this one? Did anybody want to see that expanded on? And you
Oh,
said you
yeah.
were like, yes.
Oh, yeah, someone else asked it.
Somebody else. Okay, I'm sorry. It's late in the day, and I'm getting mixed up. Sorry about that. Okay. So the last one looks a little intimidating because it does not ask for the second derivative. What does it ask for? Third. But what do you start with?
Second.
You didn't start with a second. Well, I think I see where you're going. Like, what's the original equation?
First derivative.
First derivative. So how many times are we going to have to differentiate?
2.
2 more times. To go from a first to a third, you got to go twice, right? And the other nice thing about this is some of the terms are going to be super easy. So y double prime. Any suggestions? What would be the derivative of 2? It's a constant term, derivative of which is 0. I'm not going to write anything. How about the derivative of e to the x? E to the x. The only thing you have to really do here is a power rule. Anybody know what the derivative of that third term is? Whew, that was fast. I even said it fast. Power rule. So then third derivative,
U to the x.
do it again. Yeah, the second term, like the nth derivative of e to the x is just e to the x. It just is going to be the same thing every time. So e to the x. One more power rule before we close our day out.
Plus 3/4 x to the power of -3/2.
Phew. Impressive. Now it's going to be even more impressive if you can do this. We got to plug in a 4 because that's what it wanted.
E to the 4th plus 3/4.
So e to the 4th plus 3/4 times 4 to the -3/2. Does anybody know what 4 to the -3/2 is?
Nope, I just circled back. 8.
Not 8.
6.
1 over 8. Thank you, Carson. You know how you do it? You can do it quick. Do the square root of 4. What's the square root of 4? Square root of 4? 2 cubed. And then the negative means flip it down. So I would say my final answer would be y triple prime of 4 is equal to e to the 4th plus 3/4 times 1/8 would be 3/32. Yay.
Is it all right if we just left it with the 4th plugged in, or do you want us to take the next step?
So you got to be good at both. There are going to be times when leaving it like that is just fine because that's equivalent. No big deal. If it's a multiple choice, to be able to match it up, you're going to be able to need to simplify it. So I would just say be good at both and then be smart and strategic with what you spend your energy on.
Okay.
Yeah. All right. It's wonderful to work with you guys. You're doing great. Don't forget your quizzes tomorrow. We'll be on to derivative skills 2, if I remember right. Let's find out. We have a quiz tomorrow on rates of change.
Is it a quiz or a reading?
It's a regular quiz. Review quiz, I think we have one next week, I want to say.
Will you be here tomorrow morning if you want to do it?
Yep, I'll be here tomorrow morning. Betcha. Oh, there's our practice. Yes, we are totally. Yes. We're gonna. Oh, this is gonna be so fun. Oh, I love this. I love this.